Hi everybody, it's your old pal Mr. Cook, and we're going to work on difference quotient and primarily just the fundamental parts of the difference quotient. Let's start with the quotient itself. It's written out like this: f of x plus h minus f of x, and that whole thing over h. Okay, so this is how it looks. It looks a little bit intimidating because of all the different variable values there and the fact that it's a fraction, but it's really not that bad. Usually we'll be given a function, I'll make up a function. The hardest ones that we deal with are the quadratics, so I'll just, use a quadratic, might as well. So let's say f of x is equal to x squared plus 2x plus 5. So that's the function that we're going to use as we evaluate it and do the difference quotient. So back to the difference quotient. This part of it, where it says f of x, that's just going to be the original function itself. So whatever we were given as our original function, in this case it was x squared plus 2x plus 5, that's just going to go right over here. Okay? So, if we wanted to start writing this in here, we can do that. Because really it's just three things that we need to find: f of x plus h, f of x, and h. And we already know that h is always going to be the same. It's in the bottom. The f of x is the function that we start with. So in this case it's x squared plus 2x plus 5. Now here's an important part that you need to remember. We're subtracting that function away. So we're subtracting this whole entire thing. So just putting a negative sign in front of it doesn't really do the whole subtraction part of it. We need to subtract the entire equation, so we need to put parentheses around it as well. Now, this part of it, the f of x plus h, seems a little bit challenging for a lot of you guys. So I'm going to try and break it down a little bit more so we can get an understanding of what f of x plus h really means, okay? So let's go over to the original function that we started with. So in this function, the x value, all it is, remember back to our notes, it's just the input. So whatever the input value is going to be, and whatever that value is, it takes the place of the x here and the x over here. So, for an example, if I were to plug in the number 5, okay, the number 5, I would just plug it in for x here and for x over here. So I'd get 5 squared plus 2 times 5, and then plus 5. And then I can evaluate it from there using order of operations. Nothing particularly crazy about any of that stuff. Okay, well, what if I used a different number, like a negative number, okay? It would do the exact same thing. If I use -2, I'd plug in -2 for my input value. So wherever I see an x, I'd plug in a -2 squared, plus 2 times -2 plus 5, and then I'd evaluate it again using order of operations. So really, wherever there's an x in the equation, that's where I put in the input value here. So I'm going to try something different. I'm just going to try and leave it blank. So f of blank, whatever my input, is going to be equal to that number, whatever it is, blank, squared, plus 2 times, the input, whatever the value is, blank, and then plus 5. So this is really how the function looks. Whatever I put here also goes here and here. So if I were to say put x plus h in there, the x plus h also goes here and here. See? So this is how we set up what becomes our f of x plus h value. Okay, so whatever we get here, just through simplifying and expanding the values, we're going to plug over here. I'm probably going to have to make a little bit more space for it. Okay, let's see what we get. So we just start evaluating this. X plus h squared. When we square something, it's the same as taking that number and multiplying it times itself. So it becomes x plus h times x plus h. And then we have a 2 times x plus h, so we can distribute that 2 in there. So we get plus 2x plus 2h, and then finally that plus 5 at the end. Okay, now we're going to use a distributive property or foiling to multiply these two binomials together. So x times x, the first number is x squared, and then x times h, which is the outer numbers, so x times h is xh. And the inner numbers, h times x is going to give me another xh. And then the last numbers, h times h is going to give me h squared. Okay, so let me finish writing all this stuff up. 2x, 2h, plus 5. There we go. Now I'm going to combine all the like terms. Well, I don't have any other x squares. I have two xh's, so I'll combine those together. So that gives me 2xh. I don't have any h squares other than that one. I don't have any more x values, so 2x. I don't have any more h values, so plus 2h. And I don't have any more constant values, so plus 5. So this beast right over here is going to be, the f of x plus h part of the difference quotient. And like I was saying, quadratics get nasty, and it's only because of this, because you need to expand on this part of it. And sometimes it doesn't look too pretty just because there's so many terms there. But one really, really nice thing about this is that with the difference quotient, a lot of the terms that we got over here are going to cancel out. And we're going to see that in a little bit. Okay, so we're going to plug this whole entire expression here in for that f of x plus h on our difference quotient. So I didn't really leave a lot of room for myself, so I'll have to write small, so forgive me for that. But we write in x squared plus 2xh plus h squared, and then plus 2x plus 2h, and then plus 5. Just barely, not enough room there. Just make a little room. Plus 5, there we go. And then parentheses x squared, there we go, and subtract it. All right. So what we do from here is just distribute the negative in and then evaluate the expression. So I'm going to need a little bit more room. So I'll try to write it down in this area right over here. So let's see what we get. So x squared, let me make sure I kind of make sure that this is the area that I'm working in. X squared plus 2xh plus h squared plus 2x plus 2h plus 5. And then I got to subtract away all this stuff. So I'm going to distribute the negative in there. So I get a negative x squared, and then a negative 2x, and then a negative 5. Okay, and that's all over h. Let's see how much of this cancels out. So let's see here. X squared and negative x squared will cancel out. 2x and negative 2x will cancel out. And then also the 5 and the negative 5 cancel out. So that's a lot of stuff that cancels out. And I'm left with just the following terms. I have a 2xh, an h squared, and a 2h, all over h. So what you'll notice when you do enough of these difference quotient problems, especially the quadratic and the linear functions, when you do the difference quotient, you're going to see a lot of stuff that cancels out. It'll simplify it quite a bit. Then you'll be able to finish it off pretty easily. So the h value will always cancel out. So if we just divide all of the h out of all these terms, we'll get our answer. So 2xh over h is just going to give us 2x. H squared over h just leaves us with a single h. And then if I have 2h divided by h, the h's cancel out and I just have plus 2. So that's the answer for our difference quotient. Doesn't look great, it has an x and an h and a constant value too, but that's actually all right. That's acceptable answer. And these same steps that I've gone through are going to be the same for every difference quotient problem that you work on. It doesn't really matter what your function is, if it's a quadratic or a linear equation or a cubic or a trigonometric function, they all work the exact same way. And this is your solution for this one particular problem, but you can bet that what you learned about the functions here is going to be the same for any function that you have, even if it has like a different name, like a g of x, and if it's an entirely different equation that you're writing out over here. So yeah, just continue on to the homework problems. Try and work on a couple of those. I hope this helped out. have a great time working on these. Thank you.